Welcome to the Veridian introductory tutorial. This tutorial will demonstrate how to set up a project in Veridian and screen the vibration in a compressor discharge pipe considering flow-induced vibration, dead leg pulsations, and small bore connections. We will be following example problems provided in the Energy Institute guideline for the avoidance of vibration-induced fatigue failure in process pipework. It is strongly recommended that all Veridian users have read and have access to this guideline as it documents the majority of the screening methodology implemented by Veridian. The guideline also provides an interpretation of the likelihood of failure values calculated by Veridian. The compressor discharge piping configuration is detailed in examples D1, D2, and D5 in the Energy Institute guideline. The process flow diagram is shown in figure D1. The compressor discharge piping has a connected recycle and relief line. The P&ID shows a connected pressure transducer, which is a small bore connection. The small bore connection is shown here. We will begin by creating a new project in Veridian. You can give the project a name. And a description. And save the project. We'll then create a new model and give the model a name. We will start off by setting up our vibration screening options. There are no reciprocating items. The compressor is not known to stall. There are no corrugated pipes. It is a gas flow, so there is no potential for slug flow. There is no high-frequency acoustic excitation. There are no valves in the pipe we are considering. There's no cavitation and flashing because it is a gas. And there are no thermal wells. For flow-induced pulsations, we'll consider the basic EI guidelines. We will define the discharge pipe between the compressor and the cooler on a single line in Veridian. Give it a record ID. The P&ID we can simply call the figure number. And we can give it a description. The pipe details we can obtain from the P&ID. We see the compressor discharge line is 8-inch, schedule 120. Click on the pipe details box, and we can enter the pipe information in this field. The outside diameter and wall thickness are automatically populated. We then select the green box, and that pipe is assigned to this record. From the process flow diagram, we can see that the compressor discharge line is stream number 7. Table D1 provides the stream data for stream number 7, which we can enter within the stream field in Veridian. Enter the values. You'll notice that we had to convert the static pressure from gauge to absolute, and we also had to convert the units of the dynamic viscosity. We do not need to enter the speed of sound. With the other information entered, Veridian can calculate it for us. Now select this stream. In order for Veridian to calculate the speed of sound, we need to save and refresh the model. If we now look at our stream details again, we see the speed of sound has been automatically calculated. We now enter that 100% of the stream flow rate is passing through this line, and we select which assessment modules we want to include. We now need to enter each of the assessment modules in order to complete the information required. We are provided information indicating that the maximum unsupported length for an 8-inch pipe is 7.3 meters. By selecting Other under the maximum supported length, we can now enter 7.3 meters. There is a centrifugal compressor driven by an electric motor. And there are two potential dead legs that can result in pulsations. There's the recycle line and the relief line. Veridian again automatically calculates the branch internal diameter, which we can compare to the automatically calculated critical diameter. If the internal diameter is less than the critical diameter, that line does not need to be considered for flow-induced pulsations. The recycle line internal diameter is greater than the critical diameter, so we do need to consider it. The branch length of the recycle line is 5.1 meters. And the closed valve provides a closed end condition. The EI likelihood of failure is 1. Small bore connection information is provided in example D5. The small bore connection is 1 inch in diameter with a weldolet fitting located mid-span on the parent pipe. The isolation valve is less than 900 pound rating, and the distance from the parent pipe to the far side of the valve is 500 millimeters. The mainline LOF is automatically populated along with the mainline schedule. Note that the mainline schedule is actually 120, however that is not defined within the Energy Institute guidelines, so the next thinner schedule is automatically selected. The calculated LOF is 0.66. The small bore LOF can be calculated without calculating the mainline LOF if the mainline LOF is known to be high or can be assumed to be high. To do this, on a new record, all that's needed is to enter the mainline pipe details, identify a stream where all that's required is a description and a phase, Turn on the small bore connection assessment, and then enter the small bore details. We then have to overwrite the mainline LOF. As before, our small bore connection LOF is calculated to be 0.66. And we can save our model.